Hello everyone. In today's lecture, we will start our second module, that is error detection, error control techniques. So here we will see the first topic, that is error detection and correction method. In this module, we are going to study different error detection and correction methods. Say in previous module, we have seen that block diagram of digital communication system, where at the transmitter we were using two blocks, that is the source encoder and source channel encoder. So these two blocks we are using at the transmitter side for encoding purpose, at the source encoder and at the channel encoder. So at the source encoder we are using different source encoding techniques that we have already seen in first module. Now the channel encoding techniques, those techniques we are going to study in this second module. So we will start with that. See, channel encoding is specially used for error detection and correction to reduce the effect of noise when your signal travels through communication channel. The noise may get added into your transmitted bit sequence. So to detect those errors, that means noise, and to correct them, these different error correction methods and detection methods are used. So those methods we are going to study in this module. So we will see what are those different methods. So before that, we will see some introduction. So whatever data we are transmitting, that data can be corrupted during the transmission because of the addition of noise. So for reliable transmission, error must be detected and corrected. So for effective communication, whatever information I want to transmit from one place to another place, so for that effective communication, these errors must be detected and corrected. So error detection and correction can be implemented at the data link layer or at the transport layer of this OSI model. We will see different types of error first here. There are two types of errors. The first one is single bit error and the second one is burst error. So we will see one by one what is single bit error. So single bit error is the error, that is means single bit error means only one bit get changed from the data unit, that is from 0 to 1 or 1 to 0. So whatever bit stream I am transmitting, if single bit is changing into the transmitted bit sequence, if single bit is changing from 0 to 1 or 1 to 0 at the receiver, then we can say that error is single bit error, only one bit is changing. So single bit error can happen if we are sending a data using parallel transmission. If I am using parallel transmission, means I am sending multiple blocks of a bits. So at that time, single bit error may occur. So for example, if 8 wires are used to send all of the 8 bits of a byte at the same time, and if one of the wire is noisy, then one bit can be corrupted in each byte. Okay. So this is about single bit error. And in serial transmission, the chances of single bit error occurs very less. Okay, so this most of the time single bit error occur during the parallel transmission. Now through this diagram, the single bit error can be explained. So here I have sent one bit stream, represents 0 in terms of zeros and 1, and this 0 here have changed from 0 to 1 in the received bit sequence. So that is that means the bit error occur in a single bit or single position of the transmitted bit sequence, so that is called as a single bit error. Now the error, the second type of error, that is burst type. So in this burst type of error, the bit sequence transmitted, so here the error occur in multiple bits. Okay, we can say here a sequence of bits changing its position from 0 to 1 or 1 to 0. So here we can see here the sent sequence and the received sequence, the number of bits, 5 bits have changed the values from 0 to 1 or 1 to 0. So these are the burst type of error. So burst error means two or more bits in the data unit are changing. The burst error most likely to happen in serial transmission, like the single errors are occur in parallel transmission. So burst error occur here in series transmission or serial transmission. The duration of the noise is normally longer than the duration of a bit, which means that when noise affects the data, it affects a set of bit. Okay, so here in burst we can say in bulk the bits are affected in a set. Okay, the number of bits affected depend upon the data rate and duration of the noise. So if the noise remain for maximum duration, there will be more the burst length, means number of bits in a burst set of that burst will be more. So these errors are called as a burst error. And the one more type of error is there, multiple bit error, which is unless the two bits are changing from 1 to 0 or 0 to 1. So here we can say we can see sent and received bit sequence. So in sent bit sequence I am transmitting 1, and in received it is receiving 0, and here 0 is transmitted and the received bit sequence contain 1 in that position. So when two error occur, it is called as a multiple type of bit error. So these are the total three types of error can occur in a data transmitted sequence. One is single bit error, burst error, and the multiple error. So next topic in this that is error detection. So error detection, first method we will see here for error detection. In first method of error detection, the sender will send two set of data unit. Okay, whatever data I am transmitting, it will send two sets of data unit, and the receiving device would then be able to do a bit for bit comparison between the two versions of data. Okay, so there will be comparison between those two sets bit by bit at the receiver side. If any discrepancy occur that indicates the presence of error, an appropriate correction mechanism could be set in that case. Okay, so this method would be completely accurate, but it is very slow and lengthy. The transmission time will be double, and more extra time is added for the comparison of every bit. So this method, though this method is correct, but it is not useful because of the delay time. So this another method is used called as a redundancy bit, addition of redundancy bit in error detection. So instead of repeating the entire data stream, a shorter group of bits may be appended to the end of each data unit. So whatever data I am transmitting, along with the data unit I am transmitting a small bit sequence, that means a group of bit is appended with that data unit transmitted. So this technique is called as a redundancy because of the extra bits are redundant to the information. So whatever extra bit I am transmitting, those bits doesn't carry any information, so those bits are called as a redundant bit, and they are discarded as soon as the accuracy of the transmission has been determined. Okay, so once we detect at the receiver if the code is correct, then those bits, redundancy bits, can be discarded at the receiver. Once the data stream has generated, it passes through device that analyzes it and adds on appropriate coded redundancy check. The data unit is now enlarged by several bits, travels over the link to the receiver, and the receiver passes the checking criteria. The data portion of that data unit is accepted and the redundant bits are discarded. That's how the redundant bits are discarded. In the second method, means few bits are added as a redundancy bit while transmission along with the data bits, and once at the receiver, when the original data bits are recovered, these redundancy bits are then discarded. So this is the second type of method which is useful for error detection actually. So that method is mostly used. So here is a redundancy. Through this diagram we can get idea about the redundancy. Suppose this is the data bit, at the center side we have this data bit to be transmitted, and the generating function will generate a redundancy check, means number of bits to be appended along with the data bits before the transmission. So these bits are generated by this generating function, and those bits now during the transmission, those bits are sent along with the data bits. Okay, so this yellow bits indicates the redundancy bits which we have added extra along with the data bits through this sender towards receiver, and at receiver a checking function used will check those bits, and if the received word is correct, then those added redundancy bits are then discarded at the receiver side. So this is about redundancy. And we will see error detection methods. So which different error detection methods are used. So there are these four methods. Actually, three main methods are there: parity, checksum, and CRC method. So again, parity methods is parity check method is again divided into two types, that is VRC and LRC. So these VRC and LRC are the types of parity checking method. Then CRC, cyclic redundancy check, and the checksum, these are the three methods used for error detection. Now we will see vertical redundancy check. So here in vertical redundancy check, it is a least expensive method of error detection, often called as a parity check. So this VRC and LRC are the two types of this parity check methods. So it is very least expensive method. So what we are doing in this method, a redundant bit called as a parity bit is appended to the every data unit, so that the total number of ones in the unit becomes even. That means here we are adding one extra bit called as a parity bit along with the data bit to make the parity of transmitted bit as even. Okay, so that parity bit value can be 0 or 1 as per our data bit number of ones present in a data bit. For example, here we can say, suppose I want to transmit this bit 114 times 0 1. This is my data bits. Now the parity of this bit means number of 1 present in this data sequence is 3, that is the odd parity, and to make it even I have to add one parity bit which make this data sequence even parity. Okay, so I have to make that parity bit as a 1. Okay, so that transmitted parity bit will be 1 along with the data bit. And suppose I have another bit sequence, data bit sequence as 1101010. So in this the parity is already even, so my parity bit will be 0 in this case. Now the even parity VRC concept we will see through this diagram. Suppose I have data to be transmitted as 114 times 0 1. So even parity generator will generate the parity bit, that is 1. The VRC parity bit to be added with the data bit sequence, okay, will be 1. So that parity bit along with the data bit sequence is now transmitted towards receiver, and the receiver there will be checking function. It will check that received word is with even parity. So if the received bit is with even parity, then we can say that there is no error. Okay, and if we are receiving a bit with odd parity, then the error may be present. Okay, so that is about the VRC. So we will see a performance of the VRC, how this system is this method is reliable. So using VRC we can detect all single bit error. If error occur a single bit, means only one bit is changing, so in that case VRC is useful. It can also detect burst error as long as the total number of bits change is odd. Okay, so if this VRC method can be useful for detecting the burst error if the number of bits changes and transmitted bit sequence is odd. Okay, so for example, here we can say, suppose we are transmitting this bit sequence with the even parity. Okay, if any 3 bits get changed, then the resulting parity will be odd and error will be detected. If there is an odd number of bit changes occur during the transmission, so those bits can be detected, because those errors can be detected here. Okay, because received bit sequence parity will be odd in that case, and the error can be detected. But if 2 bits get changed, then the resulting parity will be even and the error will not be detected. So for 2 or even bit changes, okay, or even bit errors, we can say this VRC method is not useful. Okay, so next method we will see now, longitudinal redundancy check. So in this method what we are doing, a block of bit is divided into rows and the redundant row of bit is added to the whole block. Okay, so instead of adding a single bit here, different block of a transmitted bit to be transmitted are considered. They are added into or they are divided into rows, we can say, and a redundant row of a bit is added to the whole block. So instead of sending 32 bits, it organizes them into a table and made 4 rows of 8 column. Okay, and then calculate the parity of each column and create a new row of 8 bit, which are the parity bits for the whole block. So here we are creating, we are whatever the data bit sequence we have for the transmission, we are arranging those bit sequence into one block. Okay, we are dividing them into rows and columns, and we are finding here redundant bit column wise for whole block. Okay, so through this diagram, this LRC method can be easily explained. So suppose we have these 4 blocks of data to be transmitted. Now instead of finding single parity for each block or each bit sequence, what we are doing, we are uh, here we are arranging all those bits into one block, and we are finding parity or redundant bit column wise for each column. Okay, so if we consider the last column in which all bits are 1, so parity bit for that will be 0. The second last column has a 3 0 and 1, that means parity is odd. So to make it even, we have to consider the redundant bit for this column is 1. So likewise, for all column we can find the redundant bit. So this bit is called as, this bit sequence of 10 is called as a LRC, that is longitudinal redundancy check, which we can now transmit with this data sequence. Okay, so this is the LRC we are transmitting along with the data sequence. Okay, so this LRC method is useful for detecting burst error. Okay, so this LRC increases the likelihood of detecting burst error if 2 bit patterns of the error are damaged and 2 bit exactly in the same position in another data units are also damaged. The LRC checker will not detect error in this case. Okay, so this is the drawback of LRC methods, which we can explain with this example. Suppose we have this 2 bit sequence, and if the first and last bit of each of them are damaged, making the data units to be like this. Okay, these are the 2 bit sequence. Suppose we are getting after changing the last and first bit of the data units, the errors cannot be detected by LRC. Okay, so this is about error detection. So we will stop here, and the error correction method we will see in next lecture.